What's up, y'all? I'm Tom, and this is Like a Math Class. In this video, we're going to hone in on one aspect of our quadratics, the thing that we call the A value. The A value is the piece that kind of sticks out in our standard form. We use it in our quadratic formula, but it has a certain level of importance that we're not always aware of. So I want to kind of clarify what that is and how we can find it. Let's get to it. Now, first thing I want to do is I want to bring your attention over here. We have a whole mess of different quadratics that are all going through the same x-intercepts here. We've got this purple one, the orange one, the green one, the red one. So all of these things might have, like even if we looked over here, they might all have the same exact x-intercepts. But clearly they're not all the same quadratic. What differentiates these values is this thing called the A value. In our factored form, we typically say we have y equals a times x minus m times x minus n, and these two things represent the x-intercepts, This A value is what I like to say is it locks you in, or it pulls you to a specific quadratic. So for each one of these, the purple, the orange, the green, the red, they're all going to have the same exact values of m and n. But when you put in a different value for A, maybe you're getting a negative quadratic. You're getting one that opens down. Maybe if you're putting in 1/2, you're getting one that looks like this. Or maybe you're putting in a value of 3 and it's stretching down this way. So that A value is what really determines what makes the quadratic its unique self. Otherwise, we have an infinite number of quadratics always going through the same x-intercepts. So how do we find the equation? We could take these two intercepts. We know that here we've got an intercept of 2, and here we've got an intercept of 5. They're crossing there. So we could put those in for our m and n. Here m equals 2, here n equals 5. So if I were to drop these into this equation, we have y equals a times x minus 2 times x minus 5. But just because we've got these two values in there, just like we've seen over here, we could have some other equation that goes like this. So how do we find out the specific A value that corresponds to this blue quadratic? Well, what we do is we take another value that we know to be on the quadratic and we substitute that in for our x and our y. Anytime we've got some equation and we've got more than one unknown value, there's nothing that we can do to solve to find one of the other unknown values. But if we can substitute an x and a y into here, we can then find this A value. And right up here, we have one other value that is on this graph, that is on this quadratic. So what I'm going to do is I'm going to take this value of 0, 4, and I'm going to drop it in for my x's and my y's, and that's going to leave me with just my A, and then I can find out what is the specific equation for this blue quadratic right here. So my x value is 0, my y value is 4. So I'm going to say 4 is equal to A times 0 minus 2 times 0 minus 5. All right, so let's do a little computing here. 0 minus 2 is negative 2. 0 minus 5 is negative 5. So I've got 4 is equal to A times positive 10. If I divide both sides by 10, then I know that my A value is now 2/5. So now I know my equation is y is equal to 2/5 x minus 2 times x minus 5. And now I know that this one is indeed the one that matches up with my blue equation right here. Now, depending on what other information we have, maybe you're given a formula where you have the vertex and you've got some other point. Or maybe you've got 3 points on there and you need to do a system of equations. There's a lot of different ways that you can find out what the A value is, or the A, B, and C value, or the M and the N, or the H and the K. All of those different values depending on the information that you're given. The real piece is Or the other thing that you need to make sure that you know is that when you are working through this, when you are trying to find another point to drop in here, it cannot be one of these 2 points. If you're trying to find that a value and you put in one of these 2 points, like if you're putting in one of the x-intercepts for the factored form, if you're putting in the vertex for the vertex form, what will happen is you'll cancel everything out. Let's see. So like right here, if we were to put in the value 2, 0, let's say we didn't realize that this 0, 4 was part of this or was on here. If we try to put 2, 0 into here, then of course we're going to have 0 is equal to a times 2 minus 2 times 2 minus 5. Great, we've eliminated an x and a y, so now we should be able to find out what the a value is. But as you've probably already recognized, if we do this, 2 minus 2 is 0. 0 times anything is going to wipe out this entire side. So we'll end up with 0 equals 0, and that doesn't really help us at all. So when you've got the factored form and you've got the 2 x-intercepts, you need to find another point that's not on the x-axis. Or if you've got the vertex form, you have to find another point that's not the vertex in order to substitute in to find that a value. I hope this was helpful. If it was, make sure you give me a thumbs up and help that algorithm spread the video to other people. And I'll catch you in the next video.